Okay, so I want to talk about Claude skills and some of their common failure modes, and specifically about why they fail in ways that are actually, I think, really counterintuitive, especially if you're coming from a traditional software engineering background. You really need to wrap your head around this mental model to understand what's going on. A skill is not code. It may contain code, but that's not what it is. A skill is a piece of prompt engineering lazy loaded into context. You write a markdown file with a description. The model decides or doesn't decide to pull it into context. So you are not deploying code that runs, you are deploying text that competes for the model's attention. So if a skill is text that competes for attention, then there's actually two competitions happening, not one. There's a routing competition, meaning does the skill get loaded at all, or does the model just answer directly? There's a compliance competition. Do the instructions actually shape the output according to the user's intent? So there are two competitions happening, both with different failure modes. And the interventions that fix one don't necessarily fix the other. So you have to solve them separately. So the first failure is that the skill never loads. The model just answers directly and ignores it. And from the outside, it seems like nothing happened. The user got their answer, but the specialized skill didn't fire. This happens because of a retrieval problem involving one primary field, which is the skill description. The body, the code, the examples, none of that is visible to the model at routing time. This happens because the description is doing double duty. It's not documentation. It is a semantic query language that matches descriptions to user intent. Documentation is for humans reading your repo. Descriptions are for the model at invocation time. So one area where people often go wrong is writing descriptions like documentation. For instance, this skill uses strace, perf, valgrind for debugging and profiling. But the user isn't saying, I need strace. The user is saying something along the lines of, my program is slow. This often fails because the description is indexed on the tools the skill uses, but the query is indexed on the symptom that the user has. A match isn't found, and the skill fails to fire. So to fix this scenario, you rewrite the description in the language of the symptom. Program crashes randomly, CPU at 100%, memory leak, seg fault, why is it slow? This feels weird because it reads like a list of problems instead of a list of capabilities, but the model doesn't really care about capabilities. The model cares about finding a semantic match to the exact prompt the user provided. So the second fix is about how the description is phrased. Not just what it says, something like use this skill when creating Docker files. That's passive. It's a hint. What actually works is something like always invoke this skill when the user asks about containerizing an application. Do not attempt to answer directly. Now, two things are happening there. The always marks the specialized path. It tells the model this is the route. The do not attempt directly blocks the shortcut because the model's default answer is to just answer from its training data. And here's the thing, a positive instruction alone loses to the default. A negative instruction alone is unmoored, so you need both. So the same thing applies to the name. The name of the skill is also part of the same semantic surface that the model sees. So something like Docker file generator that names the artifact. The thing the skill produces. But write Dockerfile, that names the action, the thing the user is trying to do. And the user isn't searching for a generator, the user is trying to do something. So name the action, not the artifact. Match the intent, not the output. So that's activation. Now execution failure is different. In this case, the skill did load. The instructions are in context, but the output still doesn't follow them. Specifically, the verification step at the end of the skill just didn't happen. And the output looks fine. It looks like a completed task. And unless you inspect it carefully, you don't even notice. So why does this happen? And the answer is actually pretty interesting. It's about how these models generate text in the first place. Models are autoregressive, meaning they predict one token at a time, left to right. This means the probability mass shifts towards the tokens that fit what's already been written. This is a very important concept to grasp. So the skill says something like verify each milestone against the scope before delivering. The model reads that when it loads the skill, but then it starts producing the output, and the probability mass keeps shifting towards a completed document. By the end, the strongest local signal is just we're almost done. The next natural token is a closing sentence. Meanwhile, the verification instruction is way back there, and it's competing against a local signal that says ship it. And the model just skips it. Not laziness, not disobedience. You are up against autoregressive momentum. So there's actually a quote from the model itself on this. It said, "My default mode always wins because it requires less cognitive effort and activates automatically." And yes, it is LLM introspection, which can be unreliable, but in this instance it's on point because that's exactly what's happening. So the fix for execution failure is the same shape as the fix for activation. Same principle, different application. For activation, the negative constraint blocks the model's default of answering directly. For execution, the negative constraint blocks the model's default of just quietly moving on. Here's what I mean. Instead of something like verify the milestones before delivery, that's silently skippable. You'd never know. You write something like, do not output the final document until you have produced a verification block listing each milestone and its in-scope deliverable. Now skipping that step produces visible evidence of the skip. The omission is no longer invisible. The shortcut is now expensive. So here's the through line. Take activation. Do not attempt directly blocks the default of just answering. Take execution. Do not deliver until you have output X blocks the default of just quietly moving on. Same pattern. Blocking the default with a negative constraint. Require something visible so you can tell whether the constraint held. So zooming out, these models have defaults. Paths of least resistance, baked in by pre-training and reinforced by RLHF. And if you're trying to get non-default behavior, you can't just ask nicely. Asking nicely competes with every other gradient in the system. Your prompt is a few thousand tokens sitting on top of trillions of parameters that want to do something else. So the skill of prompting is knowing which instructions are load-bearing and which are decorative. Please verify each step. Decorative. Do not deliver until you have output the verification block. Load-bearing. The difference is not politeness. The difference, it's whether the instruction can be silently ignored without consequence. So to wrap up, 2 failure modes. Activation, the skill doesn't load. The model just answers directly. You fix it with descriptions that look like symptoms, not documentation, plus imperative language that blocks the default paths. Execution, the skill loads, but the instructions get outcompeted by autoregressive momentum. You fix it with negative constraints that produce visible output. And here's the broader point. LLMs have psychology. They have defaults. Prompt engineering at the level that matters in production is the art of writing instructions that wins against those defaults. Measure what you can, force visible output where you can't. So I want to show you briefly what measuring this output looks like in practice. So the tool is called Claude Skill Tester. It's something I put together with Claude a few months ago. It runs on the Claude SDK. If you don't have that OAuth token, it falls back to Claude-P, the non-interactive CLI of Claude, and if you don't have that installed, it falls back to the API. And it is a unit test framework for the description field. You point it at a skill, it generates test queries, runs them through Claude, and reports an F1 score. F1 is just precision of activation and recall of activation balanced in a single number. So here's what a testing run looks like. I took a skill with a weak tool index description, the kind of first draft mistake everybody makes. One round of optimization, the F1 jumped from miscalibrated to production grade. No code change, only the description. And not every skill converges cleanly. Some plateau, some even might initially regress. As you can see right on the slide, this one didn't converge completely either. It got to 0.86, plateaued, and did not hit 0.90, but I only ran it for a few iterations, so I would expect more results if I let it keep running. Activation is measurable. Measurable doesn't mean always easy. And one more thing, this Claude Skill Tester also detects collisions. That's when two skills compete for the same queries. You can have a skill that scores great in isolation and still lose a significant share of its queries to a neighboring skill. Collision testing surfaces that. So the repo link is on the slide. It's MIT licensed, so feel free to use it, modify it, share it. Measure what you can, force visible output when you can't. Thank you.